All right, guys. All right. Is everyone in the meeting? Is everyone in the meeting? I can see Chanda there, Eunice there. All right, and also Richard. Okay, that's good. So guys, as you're about to start your academic second year, congratulations for you for making it to this far. So there are a lot of things that will be done in organic chemistry, but one of them is to understand the basic, all right, the history, and also try to get it so that you won't be stuck at some point as we are going, because it will be bulk. All right. Yes. Yeah. It is. Yes, Yun. Yes. Yeah. Your question. Yes, so industrial, pure chemistry, pure biology, and also education chemistry, they are all doing this. It's a major course to say. All right, so we are here to talk about introduction to atomic theory. Then the other day we'll talk about other things, reaction intermediate, followed by alkanes, everything like that. So long as don't be absent in the meeting. Tomorrow, so we'll talk something else in analytical, right? Like we are get the timetable, you saw the timetable. Okay, shall we get started? Okay, so the thing is, we need to understand what is an atom. So this atom, in fact, like it is making a lot of scientists to be busy. They don't sleep. They are not sleeping like we do. All right. So now let's get to know what is happening with this guy. So this guy, we can say, is anything that take part in a chemical reaction that can be defined like that, or you can say an atom is just the smallest thing um that makes up matter. All right, and we know matter is anything that can be physically touched, be touched, it can be felt. You get a point? So I'll say an atom is the smallest thing that makes up matter. I'll end from there. Then you can say matter, you define something like that. We already know an atom, but I'm just here to at least. Okay, so I'll say this is the smallest. Or you can say something that take part in a chemical reaction to be an atom. We will try to understand what is happening with it. Alright, so we are saying this is the smallest. This definition, it has been there since grade 12. I mean, since since we started grade 8. Alright, so we are saying this is the smallest thing that makes up matter. Alright. Alright, we know matter is anything that can be touched or anything that can be physically felt. Alright, so this atom we are talking about, let's say this is an atom. This atom we are talking about, it is actually made up of three things. Alright, so this is an atom we are talking about. Alright, let's draw it. Just we're just here to approximate or imagine things. So this is an atom to say. So this guy is made up of three particles or subparticles. So it's a particle, all right, a particle that take part in a chemical reaction, but itself as well, it has some subparticles of which are found inside there. All right, okay, so it has some subparticles which are found inside there. So these subparticles or subatomic particles which are inside there, or it is an atom is just made up of three things, by the way. We'll find electrons, or light, of which we'll study. That's where our programs are based on, studying electrons. So we'll find electrons, protons, all right, and neutrons. All right, so these things, they are making up an atom. All right, so an atom will be based on these three things. All right, so as we are talking about an atom, so what will be happening is that inside there, all right, there are protons and neutrons. All right, so protons and neutrons will be found inside there. All right, so we are just here to remind each other in case you forgot, but that's not what I'm saying to say. Yeah, I know you are listening, but let's just pay attention and see what will happen as we are talking about something. It's important. It's also a lesson on its own, meaning it's important. All right, so just pay attention even if you know them. Okay, so these protons are found at the center. Then here, okay, so around it, just around the center, they are what you call now electrons. All right, so electrons will be found outside. All right, so these protons, they are positively charged. Electrons, they are negatively charged. As for this, there's a bond that should take place because these guys, there's positive and negative. You know, wherever positive and negative is involved, you know what is happening. There's some kind of marriage or a bond which is happening there. That's the reason why electrons will be there in the shell. So this part is called a shell, right? Okay, inside this shell we'll find a lot of things such as subshell, everything like that. But prior to that, electron will be moving around the shell, all right, or just around the nucleus, specifically in the shell. All right, so as they'll be moving, there will be some kind of electron cloud because they are moving they're in motion, random motion. So let me not say random motion, they are busy moving. So what caused their movement? All right, so as electrons are inside there, there's a positive thing there, electron is a negative thing. So these things are trying to bond by all means, but because of the distance which is there, or the difference, these guys are, the negative ones are attracted to the positive ones. All right, so what is happening is that there is that bond. So this electron is in need of going to the friend or to the boyfriend, but they can't because of this shell. They are limited in their path. Let's say they are found inside there, so they are limited. They can't jump to the other side there so that they can go and marry. By that, they keep on searching for the place where they can find less or they can penetrate. As a result, they cause the movement. All right, the movement will continue until we don't know. All right, so the movement will continue. This will create electron cloud because electrons will be everywhere in the shell. All right, because they are trying to rotate, trying to figuring out which one is the path for me to go inside the boyfriend there, which is the positive one guy. That's the proton to say, or just the protons and neutrons. All right, so that is about the electron. So so that will cause the electrons, I mean the crowd, as they'll be moving like that, that will be something like a crowd like that. All right, they continue moving like that. Since they are electrons, we can't see them, they will be making some kind of crowd. So there will be crowd density in the shell. Specifically, we'll talk about the orbitals, suborbitals, everything like that. So they will cause this crowd as they will be moving because of that guy which is positive. So they are trying to touch this guy, so they are attracted by that force. All right, the force that is there is called Coulomb attraction or Coulomb force. All right, so we are not here to go into details. I'm just trying to show so that as we'll be studying reactions, we'll be able to say, oh, this is because of this. So all right, so we'll be studying electrons specifically in our study in organic chemistry. All right, our studies will be based on the movement of what? On the movement of electrons. So pay attention, we are here to understand an atom. All right, okay. So since we have said that they create that crowd, all right, this has been a challenge to most of scientists. People have been trying to study these electrons. Therefore, in our organic chemistry, we'll say electrons will be our chemistry building block of our study. All right. So in organic chemistry, electrons will be chemistry building block. All right. So electrons. All right. So electrons, guys, will be our chemist building block. All right. So if we don't understand these electrons, then you have a challenge in organic chemistry, even other chemistries. All right. So electrons will be our chemist building block. All right. All right. So as for that, many scientists, since this is our building block of our chemist, so we need to know more about these electrons. So they started studying these electrons. That was in 1897 when scientists started studying. I remember it was in 1897. All right. Then later on in 1924, yeah, that was in 1924. By then I was with my grandfather. All right, so that's a lie, guys. It's just a joke. I wasn't there. I just know the history. So in 1897, that's when they started studying electrons. But when we reached in 1924, it was found that these electrons have wave like particles. All right. So it was discovered to say it was the principle of wave duality was found, or what we call wave like particles. Or like, so these electrons were discovered to say they are waves like particles. All right. So the guy who did this was the guy well known as de Broglie. All right. So de Broglie found out that electrons, they have wave particle duality, or they behave like wave and also like particles. All right. So he came up with the wave particle duality. All right. All right. So as they were doing this, they created the guy de Broglie created this concept to say wave behave like particles. I mean, electrons behave like waves, again like particles. All right. So duality simply means two things. All right. So it was perplexing some people or some scientists. So when we talk of why this electron is a particle, all right, we know a particle will have a mass, a particle of sugar, everything like that. So in a particle we'll find mass. All right. So again, in a particle, again, we can also find momentum. A particle will always have the movement, so momentum is just the motion. All right. So but when we talk of the issue of wave, since we are saying wave and particle, the debate is on wave and particle. If this guy has electron has a mass, all right, that's a particle, then it can also move momentum, it can be in motion. That's why we are saying it's a particle. Then what about if it's a wave? If it's a wave, an electron will have frequency. We know electron have frequency. All right. Okay. So the other thing that we can talk of is electrons, they have what we call wavelength. All right. We'll be able to calculate the wavelength of an electron, something that we did in our first years. Other things we can talk are let's say diffraction, interference, everything like that, they possess those character or properties. All right, that's about two wave duality concept. It embed the wave concept and also the particle concept. So that's about it. All right, then since we are saying this, we came now after discovering this, there was another guy again who came since after de Broglie, who said in 1924, de Broglie did something. All right, then he did about wave duality, I mean a particle duality or wave particle like duality. Then another guy called in 1924 when de Broglie discovered that. Then we come now in 1926, all right, just 2 years after. Then a certain guy called Schrödinger was able to also show that electrons could be found in orbitals. All right, so the guy was called Schrödinger. All right, you find the Schrödinger equation, right? Schrödinger scientist discovered to say electrons could be found in orbitals. All right, so what are these orbitals? Orbitals is a path, or it's just a 3D region where the probability of finding an electron is higher. All right, so we are saying an orbital is a region of higher probability where we can find an electron. So orbitals are 3D shape, all right, or 3D region where the probability, maximum probability of finding an electrons is found. All right, so so that's about the definition of orbital. So you'll be asked to say, so these are the exam question, what is an orbital? You should know this. The rest, it was just a history. Are you getting me? So for orbitals, know the definition to be asked. All right, so I'll be telling you to say this concept is sensitive to an exam, it might come. So about orbital, just know the definition. You can say it's a 3D shape or a region of higher probability in a 3D space, okay, around a nucleus where an electron will be found. We all know what an orbital is, so that is not a challenge, I guess. Okay, so the probability will be just, let's say, 90% to 95% of finding an electrons, and it's for sure the guy had to come up with some theory, and this is a theory, Schrödinger equation. It summarizes his research. All right, so that is it. Since you are talking about orbitals, all right, so what is an orbital? We discovered to say is actually a place or just a region where the probability of finding an electron is higher. So since it is higher, the probability of finding an electron in this guy, we need to know some shapes or some orbitals that are just of basic. So I'll give you the shape of s orbital, p orbital. All right, these are just enough. S and P, that's where our study will be based on. S and P orbital. We'll be even comparing S and P orbitals when we write electron configuration. So this S orbitals is closer to the nucleus. That's for your own information. Let's not concentrate on that area. So to say S orbital will look like this. All right, so it's a round thing like this. All right, then P orbital, all right, so P orbital will be looking like this. All right, that is it. So this P orbital, it will be found in three ways. So there's what you call px, where we have a Cartesian there. All right, then in the x-axis, you say in the x-axis, all right, in the x-axis where we find our p x orbital. So again, the same p y will be found in the y-axis. All right, so that is it. Then in the py. So orbitals will be different because we'll talk about why there are 3 of them. So there will be pz. They just named pz because they had nowhere to go in terms of, so pz will be just bisecting these two. All right, it's more like x is equals to y in that region. Okay, so since we are saying these are the orbitals, so what will happen in actual sense when we are bonding s and p? Let's say sp hybridized. We'll talk about hybridization, by the way. Sp, I will say I'll bring s, then the p orbital will be there. All right, so that's the meaning there. That's how they'll be bonding. We bring another s, then they'll be bonding like that. All right, so they'll be bonding like that. Again, if you bring another s, another p, they'll be bonding like that. Let's say this is 2p, sp2, so these p orbitals are there. You get the point. So that's how they'll be bonding. So always is closer to the nucleus, the s orbital, and s orbital is always stronger. All right, so that's the basic structure of orbitals that we are studying. So let me get you through to what we call now, since we have these orbitals, I'll show you something, or let me give you something. So these orbitals now will be, all right, so if you see s orbital like that, all right, so this will have the shape like this in terms of if you are placing electrons. So the maximum number of electrons that can be found in p orbital is 2, so you say 2. All right, okay, so you can so even 1 electron can be there, but the maximum should be 2, like that. You get the point. Then p orbital we are from talking about, it has what? It has 3 orbitals, all right, in it. So these are the orbitals now. So the maximum we can see it is 8, so only electrons should be paired like that. It's more like a negative and positive spinning. Though as for this, we are saying p orbital will have the maximum number of 6 electrons. All right, this is just the maximum. It can hold even 1, but the maximum is 6. For this guy is 2, like that. Okay, so master like that, and you will see how they can be these orbitals, how they can behave in terms of sharing some electrons, making what we call hybridization. So we said a shell is just a what? It's just a pathway followed by electrons. All right, then orbitals are the one describing the original area, or just the path, the maximum where we find an electrons. That's about orbitals. That's why our start, we are putting electrons in the orbitals. All right, okay, so we are putting electrons in the orbitals. Then there's what we call subshell, of which we don't, a subshell is just like a path. Let's say this is the path within a boundary where an electron will be found, but specifically where? In the orbital. So orbital are there, which are just much of highlighted yellow. All right, so electron configuration also should be shown. Let's say I want to show you how to light electron configuration. So I'll say, let's say for carbon, it has what? The number of electrons is 6, like that. Okay, so as for this, we'll bring what we call now, you know how to light electron configuration. I'll teach in the next video, guys. That should be for carbon, it has 6. So that will be in the next lesson. I mean in the next lesson, yes, or just third lesson. So what we do is an electron configuration. I'll just light it first. So the electron configuration for carbon is 2s. All right, 2s again, then 2p, like that. All right, so here there are 2 maximum, again 2 here. I've remained with what? This is 4. All right, I've remained with 2, so I'll put 2 there. Okay, so we should know how to light the ground state and also excited state. So I've not changed anything, so this is what we call now the ground state. All right, ground state. Okay, there's what we call an excited state electron configuration, but can I just show you? All right, so what will happen is I'm going to say, you know, let's present what will be happening. You have seen here there's 2s. All right, let me start with 1s. All right, so there's 1s there, right? should have a maximum. We can see from this guy, I'm just presenting in orbital diagram. So there's also what we call 2s. So this 2s is also having what, 2 electrons, we can see there. All right, then there's what we call now 2p. all right, so this 2p, we said it can hold maximum of 6. It has 3 orbitals, by the way. So we put, there are only 2 electrons, so I put 1, you get 2 like that. So they are loose. Why I've just put 1 in the second, why not 2 in the first? They are loose. I don't want others to just stay hanging like that. They are in the same energy level too. All right, so since they are in the same energy level too, that's where now we can pair. We can't pair with the smallest energy, 1s. So this guy can borrow 1 and put there, or you get the point. So this will be 1s with 2 electrons. All right, then there will be now there 2s with 1 electron. All right, then there will be now 2p with now excited state, or they have borrowed some electrons. So we can fill there 1, we can fill there 1, we can put 1 there. All right, so this guy now, if we were to write the electron configuration of now, it is now excited because the electrons has been moved to the other place. So this guy, the orbital is excited, specifically for p orbital. So what we are going to do is, we'll say the electron configuration now will be 1s with 2 electrons, then 2s with just 1 electrons, then you say 2p now with 3 electrons. So this is what we call excited state. All right, so we'll talk more about electron configuration. So that's how the hybridization takes. So this is now, since s and p has formed the hybridization, so in this case, under this there's a p orbital, right, and also electron from s. All right, and also a space for p. So this will call as sp hybridization. Hybridization is just the combining of these orbitals. So that is it. So we'll talk about hybridization on its own, but for now let's just get to know that we have started chemistry. So electron configuration, I am here to tell, to say, is one of exam thing or concept. Know how to write electron configuration. Make sure that you get to be present in the next video, where we'll be talking about electron configuration, everything like that, and also other things to say, hyperconjugation, inductive effect, everything like that. Also other things that you know that you cover in your second year organic chemistry. So thank you for listening, and also paying attention to the history of an atom. That is all about an atom. I've talked about 2 things being an exam standard, so make sure that you get to understand these things we have talked, and they should just be in your mind. Then they'll be applied somewhere, of which you can't tell right now in an exam. Please make sure that you follow our lessons, subscribe, tell other people also to join, guys. Don't just be learning alone. Yes, let's meet in the group. All right, bye.